Vector summation and integral calculus. Vector summation and integral calculus, the topic in which we are proceeding with explanation and example. Can we divide our problem into n different parts and then solve part by part and then sum it? Okay, while summing it, there is a scenario where the n different part what we have divided our problem into n different part n tends to infinity. In that way, we will come to integral calculus. What is integral calculus? If I am adding something repeatedly for x number of times, then it will become dx. What I'm trying to say is, if I am multiplying, if I am adding a item, if I'm adding item called 5 plus 5 plus 5 plus 5 x times, then it can be written as 5 into x, so repeated summation to multiplication. 5 into x. It can be rewritten as 5 dx. Why you need 5 dx? 5x is enough, right? 5x is enough. Why you need 5 dx? Anyone would ask, yeah, I understand. You will get the same result if you do 5 into d. D is for integration. D. Someone should have put there ix, but anyway, 5 into dx, 5 into dx. Okay, 5 into dx. D is placed to symbolize that this multiplication, that is actually 5 into x, will be computed through integral calculus. Means it will be computed through drawing the graph. If I have graph, this is x-axis, this is x-axis, and this is y-axis. If I have a graph and this is x-axis and this is y-axis, in that case, if this is x-axis, this is y-axis, I have an amount called 5. Okay, 5 means vertical is 5. If I have an amount called 5, and for every x equal to 1, 2, 3, 4, it is 5 only. Then if I draw x and 5 a rectangle, calculating the area of the rectangle is same as 5 into x. What is 5 dx? That is 5 dx. Calculating multiplication through area is integral calculus. Integral calculus has taken a technology. In that technology, we compute the multiplication by calculation of the area. That if I say, I have a new technology. Okay, what is your new technology? If you are saying, if you are saying 5 into x, yeah, I'm saying 5 into x. One technology is to get 5 into x, you have to add 5x times. That is one technology. That is a technology. This getting the multiplication through repeated addition. 5 plus 5 plus 5 plus 5x times. There is another technology. Take x-axis and take width of x and height of 5. Draw a rectangle and somehow you calculate the area of the rectangle. That area will be same as 5 into x. Okay, the calculating multiplication through area, that is called integral calculus. That science, that methodology is stolen in the another name called integral calculus. 5, then it will be written as 5 into x, rather than that 5 into dx. D is for delta, that is completely false. D has nothing to do with the delta. D is just placed there to symbolize it is integral calculus. Now, means 5 into x will be calculated through graphical way, not through any other way. That is integral calculus. But what is problem? Okay, that is integral calculus. I believe it is all right. Okay, now we are proceeding in this direction where repeated summation. Okay, now we have the biggest guy is multiplication. If this is multiplication, there are many way multiplication can be achieved. One way is repeated summation. Repeated summation. One way is integral calculus, graphical way. There can be other ways also. Or if I have something in repeated summation, it can be brought it to multiplication. And if it is multiplication, it can be brought to integral calculus. At the end, repeated summation can be solved through integral calculus. Makes sense? This is the concept that we are pursuing. If hope. Okay, this is called multiplication. This is a multiplier. This is an entity that is called, this is an entity and it is called multiplication. It is a multiplier. If it is a multiplier, then there are many ways multiplication can be achieved. Many ways. One of the way is repeated summation. One of the way is graphical way, integral calculus. There can be another way. If I have a repeated summation, the repeated summation can be brought to multiplication and then multiplication can be achieved through integral calculus. What I am saying is repeated addition can be solved through the integral calculus. This is what we are saying. Like sine 1 plus sine 0 plus sine 1 plus sine 2 plus sine 3 plus sine 4 plus sine 5 up to sine n, sine n. Okay, how it can be computed? It is not a repeated addition. Repeated addition means same item should be added. I have sinusoidal of 0 plus sinusoidal of 1 plus sinusoidal of 2 plus sinusoidal of 3 plus sinusoidal of n. Any n that I can place it. Any n. Okay, if that is the case, can you compute this this addition? Okay, I could have done it easily, provided if it had a repeated addition. This is not a repeated addition. We can make it repeated addition. We will push what is your variable now? N is variable, where n can be anything. Make n as fixed. Make n as fixed. If you make n as fixed, then introduce another variable called x, where you have repeated addition. Now, what is repeated addition? Repeated addition is sinusoidal in bracket n minus x plus sinusoidal n minus x plus sinusoidal n minus x. This is what you are keep on adding. So if someone has, now we have repeated addition. I have a repeated addition sine in bracket n minus x plus sine in bracket n minus x. Repeated addition can be brought to multiplication and multiplication can be solved through integral calculus. Okay, so sine n minus x plus sine n minus x how many times? Okay, x time. Okay, x time means x is varying here. X is 0, x is 1. If I'm saying how many times x can be anything. X can be 0, x can be 1, x can be 2, x can be anything. Okay, what do you mean? If you say repeated addition means everything is fixed. Yeah, everything is fixed. See, it is same. Sine and in bracket n minus x plus sine in bracket n minus 1. It is repeated only x time. Okay, what I'm trying to say is that if this is x-axis, then this is first time, second time, third time, fourth time, x time. X time we have vertical and each vertical is sine in bracket n minus x. 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 If I keep adding for x time, then it will become sine n minus x into x. X number of time. Okay, sine n minus x is function over x considering n is constant. Okay, in that fashion, function over x into x, that is pure multiplication of two items. In that case, I can say the right side x as dx. It can be solved through integral calculus. Sine n minus x dx, where x is going from 0, that is true, up to n. Up to n means if I place x as 0, then it is sine n, plus x as 1, then it is sine n minus 1. Add x as n, then sine 0. Same thing what we were trying to do. Sine n plus sine n minus 1 plus sine n minus 2 up to sine of 3, sine of 2, sine of 1, sine of 0. Same. In reverse manner, we are seeing it. Then sine minus x integration will be minus cos n minus x. X is 0 to n. That will be 0 to n. Cos 0 cos 0 is 1, so it will be minus 1, and and cos n minus 0, that will be cos n. Okay, in that fashion, it will be cos n minus 1. That will be the result, I think so. Okay, cos n minus 1. Means if someone add sine 0 plus sine 1 plus sine n, that is nothing but cos n minus 1. The integration of sine is minus cos. So minus cos of, I'm sorry, integration of sine is minus cos, and then it is n minus x. So again minus will come. So minus minus will cancel out. It will be pure cos n minus x. X is going 0 to n. 1 minus sine, 1 minus cos n. 1 minus cos n. 1 minus cos n, I think so. So that will be the answer of this summation. Okay, what we did, if I have a multiplication and it has many antenna. Through any antenna you can come to multiplication, and you can use any other antenna to compute it. We achieved the repeated addition, came to multiplication, that is sine n minus x into x. But I know now it is cannot be solved direct multiplication, because first term is fx, that is function over x, and it is dependent upon next term, that is x. If I have fx into x, if I draw in a graph, this is x and this is function over x. If I draw in a graph, and if it is not a rectangle, if I draw in a graph and it is not a rectangle, if it is a rectangle flat line, then it is all right. But if it is a curved line, then area will not be fx into x. Area will be fx dx. It will be complex. Okay, I mean, if this is function over x and this is not a straight line parallel to x-axis, then it can be, this area cannot be calculated as vertical multiplied by horizontal, because everywhere vertical is different with going with the x. In that manner, it will be fx dx. People they think in many other way also. People generally what they say is, if I chop this 0 to x, consider I'm trying to calculate the area of this from 0 to x, chop this x-axis into n different parts, so that each part width will be x by n, delta x. At this point, see what is the fx. Then fx into delta x is the area. Add for all the delta x, you will get the net area, and that is fx dx. Actually, it is not true, but it can be understood in this manner also. Anyway, now we will try to calculate the calculate the Taylor series, Taylor or Maclaurin series, by dividing problem into n different parts. The way we did. The actual question in examination is sine 0 plus sine 1 plus sine 2 plus sine 3 sine n. This is the question. For this question, I divided into n different parts, and each part is sine 0, sine 1, sine 2, sine n. Each part I made sure that it will be equal, not different. In that sense, I introduced another independent variable called x, and then it will become equal part. Sine n minus x, sine n minus x, sine n minus. But how you can say like that? It all are same, because x is there, right? X may vary. This is called meta example. Meta example means we took at another level. Can I took even at another level? We will see. Okay, there can be a chance that if I introduce x, still all the component will not be the same. Still, if it is not x, then certainly sine 0, sine 1, sine 2, sine 3 up to sine n all are different, even if I divide into n different parts. Okay, but if I introduce x, then still there can be, in some scenario, it will not be the same again. If I introduce x, then n become constant and x is variable. Keep n and x variable and introduce one more called y, and see now all are same in terms of varying y. If it is still not the same, then introduce another variable called z, keeping n x y as constant, and z will vary. Now see, if all the n component we have divided into all are same, if it becomes same, then someone can start first integrating with dz, then integrating with dy, then integrating with dx, and then finally it will come in term of n, which is what is the actual question is. We will see more on it. This is something that is an area of extreme research that can we divide our problem into n different parts and make all parts look similar. Same, what similar? Same. It can be by introducing third party independent variable out there. No problem. We can push it. But at the end result should be all n different parts should look same. And then I can go for repeated addition. Okay, whatever the independent component is, for that we will try to do the integration. And then once integration comes in, then again take the another independent component and go for integration, then take another independent, go for integration. Keep doing it till the first component that actually the problem in is that will come into the picture. This is a debate of extreme research. There are other debate of extreme research that we have seen, that how to convert. If I say I have a repeated x, how this whatever we are talking anyway, whatever we talk in this series, any technical video, nothing is available in the book. So here we are fighting to bring a equal component so that repeated summation can be done. If repeated summation is there, then what is concept of bringing into integral calculus that we have seen earlier also? Okay, like if I have x-axis and if I have a repeated summation means I have x-axis and I have various section on x-axis. Against each section, I have a vertical line. Against each section, I have a vertical line. Against each section, I have a vertical line. If I connect the top of all the vertical line, then I'll get a function called fx. What you want? I want that summation of all the vertical line. There is only one vertical line against each section. I have so many sections on x-axis. Against each section on x-axis, I have so many sections on x-axis. Against each section of x-axis, I have a vertical bar. I have a value. Okay, if I touch all the top point of value, it will make a curve. Consider the equation of that curve is fx. What you want? I want summation of all the vertical line. Okay, summation of all vertical line cannot be integral calculus. Integral calculus talk about summation of vertical line multiplied by the width area. Summation of the area. Okay, but right now you said that summation of vertical can be brought into integral calculus. This is what you did. Sine n minus x plus sine n minus x. But all vertical should be of same height. Then it will fall into category of repeated addition. Okay, why it will not come into the picture? So if I have a width, like right now I have a width of 1, 0 to x, 0 to x. If I say 0 to n, then I have width of 1, 1, 1, 1, 1 width. Here the height is sine 0, sine 1, sine 2, sine 3, sine 4, sine 5 up to sine n. Can someone add it? Okay, if I connect all the top point of this bar, then it will be sine x. Make sense? It will be it will be sine x. When x is 0, it will be if I connect all the top bar, it will be sine n. Sine n, where n is 0, then it is sine 0. Where n is 1, sine 1, like that up to n. This is n axis. But problem is that all the height is not same. They are varying. If heights are varying, even though I have a width against each width, but between 0 and 1 and 1 and 2 and 1, 2 and 3, I can have only one vertical bar. But I cannot go with integration directly. But why you cannot go? You have fx function, you have fn function over n. Yeah, function over n is there, but integration is calculation of area. For calculation of area, I need a vertical multiplied by the width. Vertical multiplied by the width. If you have like that, then I can go for integral calculus. But you don't have like that. Only vertical are there. Okay, if I have a vertical, it covers this much width. If you get me a continuous function for which if I calculate this is f function over n. If you give me gn function over n, another function called gn, for which at any point if I calculate gn, that is the height multiplied by the width, whatever the area comes in, consider this is delta n, gn into delta 1 n. Right now it is 1. So gn into 1 or gn into delta n. Okay, if I multiply like this, then it should become fn. If you bring that kind of function, then it can be brought into integral calculus. We have seen in the past that how to bring gn if I have, or in better term, if I have fx where it is discrete value, then how I can calculate gx, which is a continuous, and for delta x, gx into delta x, the area will be same as at that point whatever the fx, that is one vertical, is there. If someone equated fx equal to gx into delta x or gx dx and then keep adjusting this to an extent and we can really find gx, then integration is possible. Or convert, these are trillion-dollar explanation. It is not available in any of the book. Someone can balance it. That is one arena of research. Another arena is if someone has fx, then bring another function. Like if I have fn function over n, sine 0, sine 1, sine 2 up to sine n. This is function over n. Change it to another function so that all the vertical are of same height. Yeah, it is sine n minus x. It is of same height. This is what your question is, right? You want the same height. Yeah, I want the same height. If this is x-axis, bring another x-axis instead of n. Keep the n constant. And then when x is 0, I have a height of sine n minus x. When x is 1, I have a height of sine n minus x. When x is 2, then I have height of sine n minus x. When x is x, then I have sine of n minus x. Okay, this is what you want. You want all the vertical to be of same height. Yeah, it is of same height. Then you can go with the integral calculus. Sine n minus x dx. Proceed. Okay, that will come as, I believe, 1 minus cos n or something like that. Anyway, now we are into Taylor and Maclaurin series. Taylor series says that if someone has any arbitrary function, then arbitrary function can be rewritten in terms of polynomial equation. What is polynomial equation? Polynomial equation is function value at any point A. Function value at any point A. If I have any function, what is the value of function at point A plus what is the differentiation of that function? The function, if I differentiate, what is the value of first order differentiation of that function that may result into another algebra? And what is that value at point A? Okay, if I say dfx by dx, I'm trying to emulate any function fx in terms of polynomial equation. If I have any function fx, what is your function fx? Fx is sine plus log x into sine plus log x in bracket into e to the power x divided by tan x. Anything, very complex function I have. Can I rewrite it as a set of polynomial equation? What is polynomial equation? Is a0 plus a1 into bracket a1 bracket x minus a whole minus a to the power 1. Or someone can say a0, 0 is the subscript, a0 into x minus a to the power 0 plus a1 into x minus a to the power 1 plus a2 into x minus a to the power 2, okay, plus a3 into x minus a to the power 3. This is the polynomial equation. Now Mr. Taylor is saying that ask that guy who has the function fx, ask for the zeroth order differentiation, don't differentiate it, and give the value at any point x equal to a. If it gives you what is your fx at x equal to a, that you write as fa, yeah, fa plus plus ask him differentiate his function and then set x equal to a and give the value. The next will be dfx by dx at x equal to a into x minus a to the power 1. The polynomial equation that is not corresponding to the any function f plus double differentiation of fx at point x equal to a into x minus a whole square by 2 plus triple differentiation of fx and then get the value that will come as a number at point x equal to a. Triple differentiation of fx into x minus a to the power 3 by factorial of 3. This is what Mr. Taylor is saying. Mr. Maclaurin is saying rather than at any a, take it as 0. Take it as 0. If you do at 0, then it will become function x at point 0 plus dfxy by dx at x equal to 0 into x rather than x minus a. So if I say same thing at x minus, Maclaurin series and Taylor series are same. Taylor is saying that if I am describing any function in term of x minus a, means that is nothing but that is a shifted function. If this is a function fx that and this is a, this function will exactly shift to a. Okay, means Mr. Taylor is trying to say that actually we cannot say that any function will pass through origin only, not required. Like if I take any line and this pass through origin, then I can say y equal to mx, but not guarantee that y is always passing through the origin. Y will pass through any point on x, negative x or positive x, then it will be complete. Okay, if I say it is cross passing through the origin, then it is incomplete because what it is not guaranteed. So it is passing through any point, it is crossing any point at x-axis at a. A can be negative also. Then it is complete. Then why? That's why he brought x minus a. Maclaurin is saying make it simple. Say x equal to a equal to 0. Then it will come as a simple man. Okay, anyway. Now can we, now question arising, how it happened like this, we have given the proof. How it happened like this, we have given the proof. What the proof is, that consider the function over x is a polynomial equation. Consider, this is what Mr. Taylor is saying. Consider function over x is a polynomial equation. Well-defined polynomial equation means a0 into x minus a to the power 0 plus a1 into x minus a to the power 1 plus a2 into x minus a to the power 2. Like it's a well-defined polynomial equation where all degrees are there. There is nothing missing here. Okay, then how I can replicate it? Then I can say any function can be replicated in polynomial equation. To replicate it, someone has to find the fx, someone has to find this polynomial equation at point x minus a. Then all will become 0. Only the first a0 will remain. In that fashion, a0 is fx at point x equal to a. So I can change a0 in the polynomial equation, I can cut it, and there I can write function of x at x equal to a. Okay, now let's go back to the original polynomial a0 into a1 in a0 plus a1 into x minus a. Differentiate one time, then a0 will go away and it will become a1, just a1, and then other will be in term of x minus a. What is its value when x equal to a? All will become 0, only a1 will remain. Means a1 equal to first differentiation. Now I can cut down a1 and there I can write dfxy by dx at x equal to a. Makes sense? Okay, now go back to the original polynomial equation a0 plus a1 x minus a plus a2 x minus a whole square. Full differentiate two times, then a1 and a0 will go away. If I see a2, then a2 will become a2 into 2, a2 into 2 into 1. That's it. And then other term will be x minus a. What will be its value when x equal to a? a2 into 2. a2 into 2 means a2 equal to double differentiation of fx at x equal to a by 2 or factorial of 2. Now I can cut down a2 and I can write double differentiation of fx at x equal to a by factorial of 2 into x minus a whole square. Plus now if I go to the original polynomial, it will be a0 plus a1 x minus a plus a2 x minus a whole square plus a3 x minus a to the power 3. Now full polynomial differentiate 3 times. Then first will go away, second will go away, third will go away, A3 will remain. A3 into 3 into 2 into 1. That's it. Plus A4, A5 all will be in term of x minus a, whatever it comes at differentiation. What is this value when x equal to a? All will become 0. Only a3 into 3 into 2 into 1 will remain. That is equal to triple differentiation of fx at x equal to a. A3 will be triple differentiation of fx by factorial of 3. I can strike A3 and I can place the triple differentiation of fx at x equal to 3, x equal to a by factorial of 3. Keep striking A4, A5 like that and you get the Taylor series. Maclaurin is saying set A equal to 0. Okay, now we have another series called meaning series. Meaning series. This is our channel name. Meaning series. What is this series? New. Can we find Taylor series? Okay, but people would say that you did not tackle down the original fx. Do you remember? What was the original fx that I don't know? You approximated, take original fx as full-fledged polynomial equation and then you start striking all the coefficients and started placing all the coefficients like a differentiation. But you did not tackle the original fx. We will tackle the original fx. Okay, consider this is the original fx. What is original fx? Consider original fx is a square. Consider Consider original fx is a square. I'm sorry, original fx is a rectangle. This is x-axis and this is y-axis. This is fx. Okay, this is x-axis, this is y-axis or function over x-axis. This line is fx. If this line is fx, what is this area? Area is fx dx integration. Fx dx integration is the area. Equal to what is the area? What is the value at x equal to 0? Okay, what is the value at x equal to 0? That is a value at x equal to 0 is function of x at x equal to 0. F0. F0 is the height. Height into x. Consider it is 0 to x. Then height at 0, x equal to 0 is f0. F0 into x is the area. Means integration fx dx, that is the area, is same as f0 into x. Now let's differentiate both side of the equal. Then it will become fx equal to f0 because x will go away and f0 is a constant. F0. This is the Taylor series. Calculating Taylor series by calculation of the area. Okay. What about this straight line? You're saying this is fx. Rather than this as fx, this as fx, I'm taking another complex thing. This is fx. Now tell me the area. Now we will divide this problem into two different parts. One part that is the triangle that looks like here. See, I made one more complex. I proceeded. Actually, this is not fx. This is fx into x to the power 0. Makes sense? This line is fx into x to the power 0. That's why it is a straight line. Now, to a straight line, I made a tilted line. Now, this equation of this line is fx equal to x. Earlier, the equation of this line was fx equal to f0, whatever it is at 0. Now, equation of this line is fx equal to x or fx equal to any constant into x. Now, now we have x to the power 1. One more terminology we brought up into the concept. Now, what is the area? Now, area is, if I draw a line here, what is the area between x equal to 0 to x? If I draw this line and this line, then there is a triangle. Triangle plus rectangle. Rectangle I know, F0. Okay. Now what is the area? This one and this one. Actually, there is not two things. The shape is like this. X equal to 0, there is an offset and shape is like this and it goes till x. What is the area? I divide it into two parts. This part and this part. Okay, this part. Now what is the full area? If this is fx, that this line is fx, then area is again fx dx going from 0 to x. Makes sense? But right hand side I have two area. One is f0 into x and plus Another is if I differentiate this angular line, if I differentiate this slant line, then it will become if what is the equation of your slant line? Then y equal to mx. That is the equation of the slant line. Then dy by dx equal to m. M means constant. That is a flat line. If I differentiate a slant line, then it will come as a constant value. That is a flat line. What is the area of the flat line? Flat line area is the this flat line height multiplied by the width. Oh, I got it. What is the area? Dy by dx into x. Oh, wait. It is not that simple. Okay, if I have a y equal to mx, then dy by dx equal to m. So dy by dx, that is the differentiable. That is coming as constant. Whereas in rectangle, simple y was a constant. If it is a rectangle, then fx equal to constant. But if it is a slant line, then dfx by dx is constant. One level up is constant. Then what is the area underneath it? Then okay, I don't know what is area underneath it. Okay, area underneath is if this is a slope, then what is this height? It is a triangle, right? Yeah. Then height multiplied by the width, height multiplied by the width by 2. That is the area of a triangle. 1 by 2 into height. What is the height? Height is the equation of this line. What is the equation of this line? Y equal to dy by dx into x. That is the equation of this line. Y equal to dy by dx into x. Okay, plus someone would say plus this much option. Okay, but anyway, we have divided into two parts. So first area is f0 into x plus another area is dy by dx into x, that is the y, into x by 2. That will be 1 by 2 dy by dx into x square. Make sense? Okay, it is same as if I say my dy by dx makes a flat line, then area of this, then flat line significance. The significance of this flat line, equation of this flat line is 1 by 2 dy by dx into x. That is the flat line. Makes sense? If I really have a flat line fx, then fx into x is the area. If I really have a flat line that is 1 by 2 dy by dx into x, that is the flat line. What is the essence of this? If this is the curve, then what is essence of this as a flat line? If I know it, then that into the x will be area because that is a constant. That essence is 1 by 2 dy by dx into x. We saw it. That is what is the I have a flat line. I have a flat line. Okay, what is a flat line? Dy by dx into x into 1 by 2. All right, it is going from 0 to x. The area will be flat line height into the width. Yeah, that is 1 by 2 dy by dx into x into x. 1 by 2 dy by dx into x square. Okay, I believe it is all right. Then what is the area of the first one? That was a rectangle. Then it is f0 into x. F0. Then what is your flat line? F0 by 1. Earlier, next is f dy by dx. Dy by dx. Where dy by dx? Where? Dy by dx has to come at some point. When x equal to 0. Hope. This is the first one and this is the second one. I am calculating dy by dx of this line, curve, slant line. At what point? At x equal to 0. At this moment, what is the dy by dx? Actual line is this. What is dy? I am talking about any fx. Any f. This is fx now. At 0, x equal to 0, what is dy by dx of this? If I know that dy by dx multiplied by x will be the height at any moment. Okay, I'm just forgetting the base offset. Okay, that height multiplied by x by 2 will be area of the triangle. That area of triangle is 1 by 2 dy by dx at x equal to 0 into x, that is the width. Okay, means if I say I have a flat line, I made slant line as a flat line. How you made? I did dy by dx. It become a constant. Okay, but that flat line is equivalent to 1 by 2 dy by dx at x equal to 0 into x. Then you can multiply by x, that is the base, to get the area as if it is a rectangle. Okay, tell me net area. Net area is integration fx dx equal to function at fx at x equal to 0 into x plus 1 by 2 differentiation of fx at x equal to 0 into x square. Make sense? Okay, now differentiate both sides. Fx equal to f0 plus dy by dx at x equal to 0 into x. Make sense? This is Taylor series. We have come to second order. What about third? No, 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 no. Who said you that it is a straight line? It is a little curved line. It is a little curved line. It is not that straight line. This is our proof. This is not a straight line. You said a straight line, right? So time to time we are increasing in complexity. First it was a straight line. Then I made a triangular line, a slant line. No, it is not a slant line. It is like this. What is this? Okay, it is like this. If it is like this, then I can divide into three sections. What is this? This is x square. What is this? This is x. What is this? This is constant. Constant y equal to constant y equal to x, y equal to x square. One more degree I came up. Now what is the area? Area is, now if I see the total area, then area underneath it plus area underneath the straight line plus area under the square. What is area underneath it? That is in question now. If I do double differentiation of x square, it will be constant. If I have y equal to any constant into x square, then if I do double differentiation of y, then it will become a constant. Oh, I got the constant. I got the constant. What is the area underneath the constant? First, you have to tell me what is the constant. Okay, if it was now this has someone has to work more on this. If it was a slant line, then whatever was the area, what is the area? The what is the straight line? That is first differentiation of fx into x divided by 2. That was a constant line. Now if it is dual, if it is dual, if it is x square, then I have to do double differentiation to get a straight line. Mean d2y by dx square will give me the straight line. Along with it, I have two terms now. Dy by dx gives a straight line. That is for slant line. But along with I have two terms. One is 1 by 2 and one is x. Because that gives the like this. That gives the okay. If I have a slant line, then what is y at any moment? Okay, that is dy by dx into x. That is the y at any moment. When x is x, then y at that moment is dy by dx into x. Dy by dx into x multiplied by x and then divided by 1 by 2 will be the area of the triangle. If I have after this, if I have something like this, first it was a rectangle, then it was a slant line. Now I have x square, some x square. Okay, now I have to find area here. Area here. If I do single differentiation of this x square, then it becomes a straight slant line. If I do double differentiation, it becomes a flat line. Make sense? If I do one differentiation, then I can calculate the area of triangle. If I do one differentiation, I can calculate the area of the triangle. Okay, for the area of triangle, what is the formula? Area of the triangle formula is 1 by 2 into dy by dx. 1 by 2 dy by dx into x square. Considering dy by dx is a straight line, dy by dx is a constant, but it is not constant here. I have to go for one more differentiation, two differentiations. So with first differentiation, that is x square, it will be 1 by 3. If it was single differentiation and it is coming to constant, then it was 1 by 2. If it is a double differentiation, then first differentiation will bring 1 by 3. Second differentiation will bring 1 by 2, the way we are saying. Because first differentiation will bring a slant line. Then if I differentiate again, then it will become a flat line. Slant line to flat line division is 1 by 2. This line to slant line division will be 1 by 3. Means the flat line what we are talking, it is 1 by 3 into 1 by 2 into d2 fx by dx square into x square. That is the flat line into x will be the area. Now I have three parts into the area. What is area? Integration fx dx equal to f0 at f0 into x plus 1 by 2 dfx by dx at x equal to 0. X into x. 1 by 2 dfx by dx at x equal to 0 into x. This is one term into x plus 1 by 3 plus 1 by 3. Okay, dfx by dfx by dx at x equal to 0. Okay, into x bracket close. Again differentiation of this 1 by 2. Again differentiation of this. Okay, and then into x at x equal to 0. Okay, it will more or less it will come as 1 by 3 into 1 by 2 into 1 by 1 into d2 fx by dx square at x equal to 0 into x square. That is a flat line into x. So it will come as 1 by factorial of 3 d2 fx by dx square x to the power 3 plus. Okay, what are you trying to say? Means when I have any fx, then fx can be drawn against x axis, and consider it has complexity of any level. Then at x equal to 0, I am trying to calculate differentiation to, to first differentiation, second differentiation, third differentiation, fourth differentiation, so that it will come level by level, so that it will become a flat line, and then I can compute the area of the rectangle. Then it will become integration fx dx equal to f0 into x plus 1 by 2 dfx by dx at x equal to 0 into x plus 1 by factorial of 3 d2 fx by dx square at x equal to 0 into x to the power 2 plus, like that we will proceed. Now let's differentiate both sides. First will become fx equal to, it will become f0 plus x square differentiation will be become 2x. F dfx by dx at x equal to 0 is constant. So it will become dfx by dx at x equal to 0 into x plus, if I differentiate x to the power 3, it will become, if I differentiate x to the power 3 one time only, it will become 3x square. 3 gone, it will become 1 by factorial of 2 d2 fx by dx square into x square plus, we'll proceed this. Okay, more in this. Okay, so we will give another example also, that how we can come to the conclusion. Is it not something like it is giving a new arena into dividing problem into n different parts, and where we are calculating area by area, and then area by area, and since area is fx dx, we differentiate it one time and we get the Taylor series. Mind blowing, amazing. This is not available in any of the book. Anyone can try. Please don't mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.